Spent some time building out a messaging app called Inbox with a few people from the ground up. It's on the App Store. Don't work there anymore. Work at a company called Bread Finance. We do basically an integration similar to Stripe for purchase financing. It looks kind of like this. This is one of our merchants. And basically what they can do is import our software or integration and then have pricing per month and consumer credit like at any given point in their like customer life cycle. Well, this is production, so that doesn't work. Okay. So today, I want to be talking about message passing and microservices, how you can set up your microservices with some message passing systems like Rabbit, ZeroMQ, or Nats. So I'm just going to talk about microservices first, message passing in general second, and then a specific design pattern for implementing your communication layer. So microservices. Let's go full screen. How do we get this to? Okay, there we go. Okay, so just a quick example of how I kind of see a microservices architecture looking. You have your clients, you have public-facing client web servers that accept either HTTP or WebSocket requests. And then behind those client-facing web servers, you have a set of microservices, each modeling a certain domain of the system. So the message passing kind of comes into play in between the client-facing web servers and the domain microservices. So this is kind of like an overall general view of a microservices system. So we're going to go into like some advantages, disadvantages of microservices. So one is that when you have microservices and you split out your domains into microservices, you can then model out each microservice with the technologies that work best for the specific domain. So if you have maybe a user microservice, you might not want to use a relational database or Mongo. You might want to use some sort of graph database, just because that is particularly well suited for something with relationships. So that's one. You can pick technology based on the domain. Two, as like organizations grow, you can then organize teams around a microservice and have them work in that silo and improve it and work at their own pace, as opposed to having it in a behemoth monolith application. They can kind of then set their own pace because everything's kind of separate from the rest of the system. The third one is that you can individually scale up services as needed. So if you have a specific service that doesn't see a whole lot of traffic, you can not scale that one up and scale up the critical service for your system completely separately. And the third is that outages can be completely contained to specific pieces of your service. So if your user microservice goes down, then maybe sign up or login maybe is down for the 10 minutes, hour, however long that piece is down, but the rest of the app still works. So that's one of the advantages. Disadvantages, especially if you're early on, like at the startup I'm at, implementing microservices requires a more complex DevOps infrastructure and a lot more complex tooling. You have to be able to, in a really fine-grained way, decide what you're going to release at what version, and you just need more tooling. It takes longer to model out because you have to really clearly define all the different services and the domains that your system needs. So that takes a little longer. Let's see. A lot of the times if you're building out a monolith application, everything is kind of centralized in one place. So if you are querying across separate domains, you can run joins and you can run in-memory operations in the same process. You don't have to go out to two separate processes, combine the results, and then do whatever sort of processing you need. So those sort of operations can take a little bit longer. And then So that last one is actually a plus, so I don't know why it's in the disadvantages. But it should be in the advantages. So intra-service discovery configuration needed. Well, we'll skip that one. This is the first time I run through this, so bear with me. So the next piece of microservice architecture in the design I'm talking about is a message passing layer or communication layer using queues. So that's the piece in between the client-facing web servers and the microservices. You can typically think of the sides on either side of the message passing system as the producers and consumers, laid out like that. So the message passing system is kind of like the brain or the network that routes everything between your web servers and your microservices. So advantages of this, there's a really, really high throughput on a lot of these message passing systems. You get to use persistent connections. So if you're on HTTP 1.1, a lot of the times you're recreating TCP connections, which can end up really hurting performance. But if you're on HTTP 2.0, then nice. Plug and play data flows. So if you have a sort of data flow between some of or if you have a microservice that accepts a create user request, you can then have other services, for example, an analytics service or a email service, also listen into that request so that the user create request, the user create microservice is actually only just creating the user. And you can plug and play other services that take care of other related operations, like emailing a new user email or updating some analytics. So that way everything's kind of sectioned off in a logical way. Disadvantages, your message passing cluster then becomes a critical point of failure. But if you're setting up a very redundant cluster with lots of nodes, that becomes less of an issue. And then you have to carefully design your communication libraries around errors and disconnects. So if one of the connections to the message passing system goes down, then this becomes a very, this becomes something you see live as an outage. Okay, so let's go to some code. So what I've done here is I've made a repo with the communication layer library that basically talks to a NATS server. And NATS is basically, have you guys used Redis before? Are you guys familiar with Redis? So the Redis pub/sub system, this is basically pub/sub with a few extended features. So what we have here, and I don't know if you guys can see this clearly. Yeah, okay. So we can imagine this directory right here as the communication library that all of our different microservices are going to leverage. And then we can imagine each of these directories as the ones with service in the name are a service. The one called producer is one of the client-facing HTTP web servers. So for example, the producer, and this is in Go, so hopefully this is exciting for some of you guys interested in Go. This is the producer, and this guy basically just accepts HTTP requests. And for each HTTP request he receives from a client, he goes out to a microservice and does and completes a certain operation. So the library we're using to connect all of these to the message passing system is a wrapper around the NATS client library. And we've simplified the interface that this library exposes to be a simple request object or a requester object. You create on each process a queue connection. You wrap it in a queue object. Then you wrap that queue object in a requester object. And then you have two basic functions that each of the web servers or the microservices are exposed. A handle function that you can basically say, hey, for any specific subject, be it user create or document create or user update or whatever it might be, let me listen in on that subject and handle all those requests. The second function exposed with this library is the request function. So if you are one of those web servers, those client-facing web servers, when you receive requests, you can then request out to the microservices using this request function. So let's see what that looks like. So one of the main points around this design is that you have to basically type out all of your subjects that are relevant. So here we have two, and for all intents and purposes, these are just strings. So we have two subjects, create.user and create.document, and so they're namespaced. And there's some interesting namespacing going on in the COM library, but we'll look at this from a higher level. So we've got the web server that's open to clients. We've got a post/user path. When that path is hit, we make a request out to the user microservice just by having this requester object and calling request with this string, which if you see at the bottom is just the create.user string. We also have a handler for the path/document, and inside of it we just make a request out to not specifically either one of the services, so not specifically the user service, not specifically the document service, but we make it out to this subject so that anyone listening on the other end can then respond to my request. So from a design perspective, these client-facing web servers actually know nothing about any one of the given microservices. They're just sending kind of things out into the ether, into this message passing system, and hoping that something is listening and handling the request and giving them a response. So we have another two services right here. One is just listening. It instantiates all the connections, and then it just listens on the create document subject, and then that's all it does. And then the user service follows in the same sort of fashion, just listens on create.user requests. So let's fire it up. We've got three sort of processes running. We've got the user service running. We've got the document service running right there. And then we've got the, where is it, producer? Anyways, the HTTP web server is running. Oh, it's server, that's what I named it. Okay, so we've got the HTTP web server running. So now let's just go out to a regular HTTP client library, and then we'll run these sort of requests, and we'll pass in to/document. We'll send a content and an author to create a document. We'll send it, and then we'll get back the ID of the document we created back. So another one of the things I kind of wanted to touch on is how quickly you can create a brand new service. So let's say we wanted to add a, someone just yell out like a certain resource you might want to create. Comment. Well, let's add a comment service. So we'll create a comment service. We'll have that guy there. We'll give it a type. Types.go. So we can define our comments. What are the fields you want to give it?
Name, date, comment.
Okay. That's my attempt at making this interactive. Okay, so I'm just going to give it name and comment just for brevity. Okay, so then we have the type ready, and then we need to just add a handler, right? So I'm just going to copy the text from one of the other services, input it in here, and the basic structure is the same. We need to instantiate the queue connection, and then we need to listen on something, but we want to listen on this time is create comment. And then here in the handler, usually you'd go out to a database and then do a certain save. I just omitted that and sent back an ID, which is supposed to represent the ID of the comment that was saved. So the last thing we have to do is we have to go out to the communication shared library and add the create comment type. Okay, so now that we have that, and this service is and should be complete, let's spin up another terminal and let's go back to the comment service and we'll run it, and if we get no errors, it works, and it does. So now the last thing we need to do is just add a handler. Context. Okay, and then we'll copy this. Except now what we want to do is we want to grab the comment type that we created before, basically a struct that just outlines what the comment looks like. The first thing we'll do is we'll try and bind or parse the request out and fill it into that struct. And then we'll make the request with the request type that we just created, which was the create comment type, and we'll pass in the comment, which I have to rename up here. Okay, and then you get the ID back, and then you respond with the ID. Okay, so assuming this was all coded correctly, then we can go back to server, and we can restart it. And it wasn't because I didn't import the other library. C-types, undefined C-types. So we got to import that library where we defined. Well, full stack comment service / types. So that's us importing the types that we defined in our comment service. And then what was the other error? It was undefined document on 63. We'll go back to the producer. We'll go back to line 63. Undefined, okay. Right, okay, well, let's see if this works.
Bind document.
Oh, right, thank you. So we'll bind on a pointer to that resource. And run. And it works, okay. So now we hit that path on the client-facing web server, just a post. We'll give it 2 fields, being the, and I forget what the fields were again. What were they? Name. And I'll just give it my name. And then it was comment. Hello world. Okay. And so if all is well, we should see this ID update, and we did. So now we have another microservice running that's handling all our comment create requests. So basically what I'm trying to get at here as a kind of takeaway, and I hit 19 minutes, so this is takeaway time. The takeaway is that if you, after you build your communication layer library and you build it out with like a simple interface, then spinning up new microservices and adding them to your production cluster should be fairly simple. So this is just an interesting way to, or an interesting pattern to maybe going about getting that started. Yeah, that's all I got. Thanks.